Okay, here's the rest of the story leading on from introduction 1. So, let's just look at these different functions. Y equals x cubed, y equals x cubed plus 1, y equals x cubed plus 2. Now, using your differentiation rules, you'll find these all quite easy. So this would be 3x squared. The second one, that part's 3x squared. Differentiating the constant gives me nothing. And differentiating this one also gives me 3x squared. Now this is where we have a problem, because if we try to integrate now, every single time I integrate these in red, they're all going to turn back into pure x cubed. So our second and third function would lose these plus 1s, so they're clearly not correct anymore. So what we have to do to show this is whenever we integrate, that means working backwards, we're going to have to add on a constant term. So if I integrate this, I'll get x cubed plus c. On the second one, I also get a plus c, because it's a constant term we didn't know what it was. And on this one, we'll also get y equals x cubed plus c. So this is indefinite integration. Obviously in this case c is 0, so we don't actually need it. In this one c was 1, and in this case c was 2. So what you've got to remember is whenever you're integrating indefinitely, you have to put plus c, because you could lose a constant term, i.e. this one and this one. So we have to be very precise in what we're doing, because otherwise, as I said, you lose the constant term. So now we're going to use our refinement to the system. So we're going to integrate 5x cubed with respect to x. That's why we have dx there. So let's go back to our basic rule to start with. We said we're going to add 1 to the power and divide by the new power. Nothing's changed there. But now we just have to remember that we do have this c term, just in case our original function had some constant term that we didn't know about, that was eliminated once we differentiated. Here's another example. So we're going to integrate 9x to the 7 with respect to x. So we're going to add 1 to the power and divide power. Not forgetting there could be a constant term that we've eliminated, so let's include it there. So the correct answer is 9x to the power 8 over 8 plus c. So it's your turn now to use all the correct notation. I'd like you to integrate 7x squared, so dy dx equals 7x squared, so integrate that one. And also dy dx equals 15x to the power 4. Those are your two. Make a note of them, press pause and have a go. And so your solutions. So we're integrating 7x squared with respect to x. So we're going to raise the power by 1 and divide by the new power, not forgetting we could have eliminated a constant term, so we need to put plus c on the end. Second one, so we're integrating 15x to the power 4 with respect to x. So we have raised the power by 1, divide by the new power, not forgetting the c term on the end, and if you notice here 15 divided by 5 is 3, so we've got 3x to the power 5 plus c.